Beneath the Geneva gloom, far below on the surface of the Earth, lies a stunning triumph of human ingenuity, and an inevitable harbinger of devastation. The Large Hadron Collider, or LHC, is a marvel of intelligent analysis, allowing scientists to probe the subatomic realm and bringing about the discovery of the elusive Higgs boson, more commonly known as the God particle. This innovation has captivated the scientific world. Yet, as renowned physicist Brian Cox once ominously declared, a hidden potential has been found at CERN, triggering a wave of wonder and worry. Could our quest for knowledge be taking us down a dangerous path? Have we chosen a course for an uncertain future that defies our understanding? Before exploring this startling possibility further, it's essential to first examine the colossal machine that is the Large Hadron Collider. Operated by CERN, the LHC is an imposing 17-mile ring of superconducting magnets. It is, by far, the largest and most powerful particle accelerator ever built. It stands as the pinnacle of scientific achievement, capable of recreating conditions that rival the birth of the universe itself. This amazing equipment enables researchers to investigate the fundamental components of the cosmos. But with such power comes unforeseen consequences, possibly even terrifying ones. Founded in 1954, CERN has become one of the most prestigious and vital research centers in the world, with 23 member countries and a large network of experts. While the LHC is its most high-profile project, it is only one part of an expansive array of accelerators and detectors aimed at comprehending the smallest building blocks of the universe. The LHC is racing to find the very components of existence. It accelerates protons to nearly the speed of light, sending them on a collision course that mimics the flow of energy and conditions present at the beginning of the universe. The temperatures produced are millions of times hotter than the sun's core, while an intricate web of magnets directs the particles on their journey. At the same time, highly sophisticated cooling systems maintain the collider's extremely icy surroundings. In fact, the LHC is colder than outer space. Equipped with 1,232 dipole magnets to steer the proton beams and 392 quadrupole magnets to focus them before they collide, another crucial type of magnet helps increase the probability of collisions by pushing particles together with incredible force. The mission is to collide particles with such precision that it is akin to hitting two needles placed 6 meters apart. The level of precision required is staggering, and the technology involved is unparalleled. The collider's concentric rings are placed deep below ground to protect them from radiation and ensure optimal performance. The entire system is kept at -456 degrees Fahrenheit, colder than even the vacuum of space. The underground setup houses 4 distinct particle detectors: ATLAS, CMS, ALICE, and LHCb. Each serves a specific function in investigating various aspects of particle physics. These detectors are equipped with massive cameras that capture the impacts, while experts constantly analyze the data in search of traces of the elusive Higgs boson. The Higgs boson is thought to be essential for understanding the very fabric of the universe, offering insight into its essential structure. In many ways, studying the microcosm helps us unravel the macrocosm of the universe, similar to deciphering a massive cryptic jigsaw puzzle. However, with each piece we place, new questions and mysteries emerge, highlighting the fact that every discovery leads to a new problem. The LHC is not merely a tool for science, it is an embodiment of human ambition, progress, and the relentless drive to comprehend the fundamental forces that shape our universe. But as we venture into the unknown, we must also confront the moral and existential dilemmas that accompany such daring exploration. What are the potential risks of delving into the unseen? Could our quest for understanding unleash forces that we can't control? In recent months, an unsettling revelation has shaken the foundation of the scientific community. Brian Cox, a former CERN researcher and prominent voice in the field of particle physics, made a statement that piqued both curiosity and concern. According to Cox, the goal of the LHC, to recreate a miniature version of the Big Bang, reproducing the very event that gave birth to our universe, could lead to unforeseen consequences. The collider's impressive ability to probe the Higgs boson and explore the enigma of dark matter, a substance that constitutes a significant portion of the universe, could potentially reveal information beyond our comprehension. While the idea of locating the darkest mysteries of the universe is thrilling, it also comes with risk. The LHC recreates the extreme conditions of the universe's inception: temperatures, pressures, and energies unlike anything observable in everyday life. It's as if we are peering into the very moment the universe began. Yet, such immense power brings with it immense responsibility. Consider the incident involving a Russian physicist, Anatoly Bugorsky. In 1978, While conducting research at a synchrotron at the Institute for High Energy Physics, a tragic accident occurred. A proton beam accidentally penetrated his skull, causing significant tissue damage, yet he miraculously remained conscious and walked to seek medical help. His experience serves as a stark illustration of the potential dangers of particle accelerators. Concerns about the LHC's undervalued capacity to create black holes, albeit on a very small scale, have raised alarms among some in the academic community. Black holes are regions of space where gravity is so strong that not even light can escape. Some scientists fear that the LHC might create a miniature black hole, one that could theoretically consume the Earth from within. While CERN scientists have reassured the public that any black holes generated would disappear almost immediately and pose no threat to the planet, these theoretical possibilities persist and have sparked both fear and intrigue. The idea of creating a black hole through high-energy particle collisions has long been controversial and has contributed to growing public awareness of the dangers associated with such experiments. Understanding the mechanics of the LHC is crucial to grasp its potential to create a black hole. When protons accelerate almost to the speed of light, the energy produced upon collision is so vast that it distorts the fabric of space-time itself, like jumping on a trampoline and bending the surface. These distortions raise a troubling question: could such shifts lead to the formation of a black hole? In the strange and mind-bending realm of quantum physics, where the fundamental laws of the universe often seem to defy logic, there exists a theory suggesting that unidentified aspects of our reality may be hidden within the fabric of space. If such components exist, they might be tapped into by the LHC, potentially sparking the creation of a gravitational anomaly capable of forming a black hole. This possibility has garnered the attention of some of the most distinguished scientists in the world. The late Stephen Hawking warned of the potential dangers of the LHC, particularly. This unprecedented volume of data is essential for detecting rare particle interactions and anomalies that could reshape our understanding of the universe. Each collision within the LHC is recorded and analyzed through complex algorithms and artificial intelligence, filtering out the noise to isolate meaningful signals, potential clues to dark matter, supersymmetry, or even extra dimensions. Yet, despite the rigorous protocols and international oversight, the question lingers: are we truly prepared for the implications of what we might find? The sheer ambition of the LHC is both awe-inspiring and humbling. It brings together not only the brightest minds in physics but also engineers, computer scientists, mathematicians, and visionaries from diverse disciplines, all united in a common goal: to answer the most profound questions of existence. What is the origin of mass? What is dark matter made of? Are there hidden dimensions? And ultimately, what is the true nature of reality? Every advancement brings us closer to the answers, but also closer to unknown consequences. The potential benefits are enormous: technological breakthroughs, a deeper understanding of cosmology, perhaps even answers to age-old philosophical and theological questions. But the risks, however small, remind us of our fragility. The LHC stands as a monument to the scientific spirit, bold, persistent, and fearless in the face of mystery. But it also serves as a mirror, reflecting the ethical dilemmas that come with such bold exploration. Are we wise enough to wield the knowledge we uncover? Can we ensure that our curiosity does not lead to irreversible harm? As the LHC prepares for its next series of upgrades and experiments, known as the High Luminosity LHC project, these questions grow even more urgent. With increased collision rates and more powerful beams, scientists hope to unlock deeper secrets. But as power increases, so too does uncertainty. The future of particle physics is thrilling and terrifying in equal measure. We are standing at the edge of a cosmic frontier, with tools powerful enough to bend the very rules of nature. Whether this leads us to enlightenment or to danger depends not only on science, but on our collective wisdom. In the end, the Large Hadron Collider is not just a machine buried beneath the Earth. It is a symbol of wonder, of risk, and of the boundless human desire to understand everything. This colossal quantity of data demands cutting-edge technology that has revolutionized fields like computer science and data science. The results from the LHC experiments go far beyond particle physics, extending into areas like medicine, material science, and even environmental studies. The study of the Higgs boson, for instance, could have far-reaching implications beyond our universe's comprehension. This fundamental component of the standard model of particle physics plays a crucial role in giving other particles mass. Without the Higgs field, the universe would be vastly different, with particles floating around in an empty, massless space. However, beyond the fundamental comprehension of the Higgs, scientists are also keen to understand how the particle behaves under extreme conditions. This research could yield insights that impact everything from the development of new materials to understanding the fundamental factors that determine the universe. Another important factor in the LHC's work is its investigation of dark matter. Dark matter is an invisible substance that accounts for around 27% of the universe's mass-energy content. Despite its immense presence, scientists have not yet directly detected dark matter. The LHC's experiments aim to reveal the potential particles that may compose it. By observing the behavior of particles created during high-energy collisions, dark matter might finally be realized. This could alter how we see the universe, unfolding spacetime's hidden dimensions and altering the foundations of modern physics. Alongside dark matter, the LHC is exploring other exotic realms like supersymmetry and the possible existence of extra dimensions. A theory called supersymmetry makes a connection between two fundamental classes of particles, bosons and fermions. This theory predicts the existence of superpartners, particles that have yet to be observed. Supersymmetry could open the door to a new understanding of the fundamental forces of nature, providing a deeper comprehension of the interactions that govern our world. Furthermore, the LHC plays a crucial role in advancing quantum computing. By understanding the behavior of subatomic particles, researchers can gain valuable insights that could revolutionize how we process quantum information. Computers based on the principles of quantum mechanics have the potential to solve problems currently beyond the reach of classical computers. Technologies developed for the LHC's experiments, such as specialized detectors and advanced computing algorithms, have already influenced the field of quantum computing, paving the way for future breakthroughs. Despite the unquestionable advantages of the LHC's work, it also raises fundamental concerns regarding the future of humanity. The search for the unknown can be exhilarating, but it also comes with the responsibility of considering possible unintended consequences. The very technology that drives the LHC could be used for purposes that might harm humanity, such as in the progression of advanced weapons or in creating ethical dilemmas beyond our control. Concerns surrounding the LHC are not limited to the risks of catastrophic events like black holes or vacuum decay, but also include the potential applications of the research. How do we ensure that this knowledge is used responsibly and that the pursuit of discovery does not inadvertently lead to harm? As we explore the unknown, it is crucial to engage in ongoing conversations about the balance between scientific progress and ethical responsibility. The global nature of the LHC's work requires the cooperation of multiple countries, each with their own values, priorities, and concerns. Transparency in research, accountability, and collaboration between nations will be essential in ensuring that the knowledge gained through these experiments benefits humanity as a whole, rather than causing unforeseen damage. The work of CERN through the LHC serves as a reminder that scientific achievement must always be tempered with careful consideration of its broader consequences. Another issue of concern is the potential for unforeseen ecological impacts of particle accelerators. While the LHC is a relatively contained environment with no immediate effects on the surroundings, the enormous energy requirements of such machines are worth noting. The environmental footprint of particle accelerators, especially those requiring large quantities of electricity and producing heat, could strain natural ecosystems and resources. The energy demands of the LHC are immense. Although efforts are being made to use energy from renewable sources and enhance efficiency, the larger issue of sustainable research in science must be addressed. In the end, the path forward will require a delicate balance. The LHC represents humanity's drive for knowledge, exploration, and discovery. However, with every scientific breakthrough comes the need for ethical reflection and responsibility. The risks involved in such experiments cannot be ignored, but the potential rewards could reshape our understanding of the universe in ways we can only begin to imagine. As we continue this journey into the unknown, the focus must be on ensuring that the pursuit of scientific progress is carried out in a manner that is safe, responsible, and beneficial for future generations. In conclusion, the Big Hadron Collider is much more than just a tool for scientific discovery. It is a symbol of humanity's quest for knowledge and its never-ending fascination with the nature of existence. The questions raised by the LHC's work are profound and carry significant ethical and existential considerations. Additionally, the LHC demonstrates that through collaboration and careful oversight, humanity can unlock secrets that have the potential to change the course of history. As we stand on the precipice of these new discoveries, we must remain vigilant, mindful of the potential risks, and committed to the ethical use of the knowledge we uncover. In the end, the quest for understanding must always be guided by the obligation to safeguard our future. As the capabilities of the LHC continue to expand, so too does our responsibility to anticipate the broader impact of its findings. Future upgrades, such as the High Luminosity Large Hadron Collider, HLLHC, promise even more precise measurements and a higher volume of data. With this advancement comes the opportunity to probe deeper into the mysteries of dark energy, test the limits of the Standard Model, and possibly uncover phenomena that challenge our current understanding of physics. The ripple effects of these discoveries extend well beyond the realm of science. Breakthroughs in physics often serve as catalysts for technological innovations that permeate our daily lives, just as the World Wide Web was born at CERN, originally created to meet the demand for information sharing between physicists. The next transformative technology might very well be incubated within the same halls. Moreover, the LHC fosters international unity. In a world often divided by borders, politics, and ideologies, projects like the LHC represent a rare example of global cooperation for the common good. Scientists from over 100 countries collaborate not for personal gain, but for the enrichment of collective human knowledge. This cooperative spirit sets an example for how humanity can face complex challenges, like climate change or pandemics, when united by a shared mission. Yet, the ethical dilemmas remain. Who decides what scientific boundaries should not be crossed? How do we govern discoveries whose consequences we may not yet fully understand? These are questions that must be addressed not only by scientists, but by ethicists, policymakers, and the global public. The democratization of science, making its goals, processes, and potential outcomes transparent, is essential to ensuring accountability. Ultimately, the story of the LHC is not just a story about particles and collisions, it's a story about curiosity, ambition, and the human spirit. It challenges us to look beyond what is visible and to seek answers to the most profound questions. What are we made of? Why are we here? What lies beyond the edge of the known universe? As long as we approach these questions with humility, responsibility, and a deep respect for the impact of our knowledge, the journey ahead will not only illuminate the universe, it will elevate humanity.